Is this audible? Is this audible?
Sir,
Okay, there's some internet issue. I have changed my location. Let us see. Okay, now this is the given problem, and we need to find sigma. Give me a moment. We need to find sigma normal, sigma tangential, sigma p1, sigma p2, theta p1, theta p2, tau max, tau min. Okay, theta s1, theta s2, and we should represent the same and represent the same. Okay, now the formulas we know, can write sigma normal, sigma normal. First I'll write sigma normal, which is equal to can anybody tell me the formula? Sigma x, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. And in this problem, he has given the plane as oriented. There is a plane on which we should find the normal and the tangential stress. There is a plane on which we should find the normal and tangential stress. That plane makes an angle 45 degree with respect to this. Since theta measured is counterclockwise direction, theta is equal to plus 45 degree. Okay, from the vertical top drop, sweep the clock, theta measure counterclockwise, and then theta is 45 degrees positive. Okay, next, sigma n is given by this. I'll substitute directly. You should tell me fast, which is equal to 80 plus 40 by 2 plus 80 minus 40 by 2 cos theta is 90 cos 2 into 45, which this will be 0, plus tau is positive, tau is 60 into sine 90. Can tell me what is sigma n? I'll write sigma t which is equal to minus of minus of sigma x minus sigma y by 2 into sin 2 theta plus tau xy cos 2 theta, or which is equal to minus of sigma x minus sigma y 80 minus 40 by 2 sin 90 plus tau xy 60 cos 90. Right? Can you tell me this? Which is equal to minus 80 minus 40, 80 minus 40, 40, 40, 20, minus 20 MPa. Minus 20 MPa. And you tell me sigma n. What is sigma n? 80 plus 45, 60. How much are getting?
120, sir.
120 MPa. Time being, you adjust 1 or 2 classes. If I get habituated, I will do it. Since this is a new environment, I find little difficulty. If some other faculty start the class, obviously the internet drops. That's the problem. Okay. Next, we got sigma n and sigma n. See, we made a thumb rule that if sigma t is negative, or in this case negative, then it rotates S1 phase in which direction? Then it rotates S1 phase in clockwise direction. If it would have been positive, it would have been rotated in the anti-clockwise direction. Sigma t or tau, we can say sigma t or tau. Okay, we have made that. And next, sigma 1. See, previously what we did was we found the tan 2 theta, and then we substituted the theta p to find sigma 1 and sigma 2. But readily we have sigma 1 in terms of sigma x, sigma y and tau xy. So we will be writing sigma 1 and sigma 2 directly. Sigma 1, which is equal to sigma x plus sigma y by 2 plus root sigma x sigma x minus sigma y by 2 the whole square plus tau square xy, which is equal to 80 plus 40 by 2 plus root 80 minus 40 is 40, 40 by 2, 20 square, 80 minus 40, this is whole square plus tau square xy. Tau is how much? Tau is 60. 60 square. Sigma 2 will be, therefore sigma 1 you calculate and tell me. Sigma 2 is sigma x plus sigma y by 2. Sigma x plus sigma y by 2 minus root sigma x minus sigma y by 2 the whole square plus tau square xy. Okay, which you should do. Only the sign changes here, plus and minus. Plus and minus. Tell me this, sigma 1 and sigma 2. What is sigma 1 and sigma 2? Yes. Eighty minus 40 by 2 is 40 by 2 is 20 square plus 60 square. 60 plus 20 square plus 60 square, root of that. How much is that? How much?
Sir, sigma 1 is 123.245.
Yes, 123.245. 123.245 245 MPa. Sigma 2, shall I write directly? Minus how much?
3.425.
3.245,
245.
right?
3.3.
245 MPa. To find the principal planes, we found the magnitude of the principal stress. In order to find the principal planes where the magnitude of the principal stresses are maximum, principal planes are given by, shall I write, tan 2 theta p is equal to 2 tau xy by sigma x and sigma y, which is equal to 2 into 60 by sigma x minus sigma y is 40, or theta p is equal to how much? Tell me. Theta p, we'll find whether it's theta p1 or theta p2, we should decide. Theta p, tell me. How much?
3, sir.
Tan inverse 3, you do it. Tan inverse 3.
71.56.
Now this 2 theta p is equal to 71.56.
56.
2 theta p is equal to 71.56 degree. Okay. Therefore, theta p would be
35.78.
theta p, which is equal to 35.78 degree. Okay. See, since sigma x minus sigma y, which is equal to 80 minus 40, which is equal to 40, is positive. Therefore, theta p gives the direction of sigma 1, that is theta p is equal to theta p1. If it would have been negative, then theta p gives the direction of sigma 2, then theta p is equal to theta p2. Okay, according to our convention. Now it gives the direction of theta p1. Now let us represent that. Take this angular x, y, okay, theta, this is equal to, let me write, therefore theta p1, which is equal to 35.78, theta p2 is equal to theta p1 plus 35.78, sorry, theta p2, which is equal to theta p1 plus 90. How much would be this? 125.7825, 125.7825. Okay. Now theta p1, since theta p1 is positive, you just indicate, if you want to indicate in protractor, you can indicate, or you can just draw a line at certain angle, approximately 35 to 30 degree, indicating this is theta p1, which is equal to 35.78 degree. Perpendicular to it will be your theta p2, this is plane p1, plane p2, and draw the plane. Don't talk, draw the plane. Draw the plane. This is theta p1. This is 90 plus 90 plus theta p1 is equal to theta p2. This is p2. Can you mute your mic? Next. Next, I have to indicate sigma 1 and sigma 2. Here, sigma 1 is of magnitude 123 and minus 3.245. I will indicate. Mute your mic. Who is that? Umesh, mute your mic. Umesh, mute your mic. Sigma 1, which is 123.245. Let me represent that. Since we are tensile, I will represent 123 sigma 1, which is equal to 123.245 on this plane. This is acting on P1 plane, sigma 1. Sigma 2 is compressive, indicated here, sigma 2, which is equal to minus 3.2455. Find theta p1 and theta p2, sigma p1 and sigma p2. Let us go to maximum shear stress. maximum shear stress. I can write. I can write theta S1 first since theta P1 is positive, therefore theta S1 is equal to theta P1 minus 45 degree. Right? We have discussed that. Therefore, theta S1 is equal to theta P1, which is equal to 35.78 minus 45. Can you tell me this? Theta S2 is equal to theta S1 plus 90 degree. How much? How much theta S1? Since theta P1 is positive, theta S1 is equal to theta P1 minus 45. How much theta S1? 35.78 minus 45. How much it is? How much? Minus 9.218. Tell me theta S2. Tell me theta S2. Theta S2?
80.78, sir.
80.78. For this class only, next class only 80.78. Okay. Uh, These planes are also accompanied with normal stress. That normal stress is given by sigma average, which is equal to sigma x plus sigma y by 2, which is equal to 80 plus 40 by 2, which is equal to 60 MPa. 60 MPa. Now, we already came to a conclusion that sigma t is minus 20, therefore it will rotate S1 phase in clockwise direction. Let me represent that. X, Y, theta S1, I should talk with respect to theta S1, minus 9.28, minus in the sense it is clockwise direction. I will just draw a line at minus 9.28 plus 1 plane, and I will continue like this, minus 9.28, I will continue, and perpendicular to this will be your S2 plane. S2 plane. This is theta S1 is equal to minus 9.28 degree. And this two will be perpendicular. Obviously, this will be 80 point something. If I draw the plane, plane will be like this. This plane should draw properly. Assume this is minus 9.28. This is just some plane. On this plane, this should be perpendicular. Even though I have written like this line and this line should be perpendicular. I cannot write. Shall I write in the next page? Okay. I'll write it here. xy. Theta s1 is minus 9.28. This is theta s1 is equal to minus 9.218. Continue like that. Perpendicular to that will be your S1, this is S1 plane, this is S2 plane. Draw the body. S1 perpendicular to S1 plane, S2 plane. Okay. Now, uh, now I need to indicate, since S1, this tau is acting in clockwise direction, it should be in clockwise direction. Tau should be in clockwise direction. This is equal to tau or sigma t, which is of magnitude minus 20 MPa, which is sorry, which is we are not found sigma max, right? Sorry, tau max were not found. Okay, sorry, I made a mistake. I didn't made a mistake, but I have skipped that step. Tau max, tau max. Yeah, have you found it tau max? No, I think no. I directly found the planes. I have not spoken about tau max. We have found sigma normal and sigma tangential. It means to say that on this plane, what is the normal stress and tangential stress we have found it. We have found the principal stress. I skipped that step. Let me complete that. Tau max is given by tau max, which is equal to moment. Okay. What is tau max? Can anybody recall? What is tau max? Anybody recall? Any of you recall tau max? I have not written that step. Don't recall. Tau max is given by, give me a moment. Okay. Okay, you can use this tau max, which is equal to, directly you will use this step, which I will take from new session also. What he has done for tau max is taken sigma 1 minus sigma 2 by 2, or you can do like this. Tau max is according to this, what I will do, I will write okay. Okay, I will use this same formula. Okay, this is the formula for tau max. Tau max or tau minimum. Tau max or tau minimum, you can write tau max only, which is equal to root sigma x minus sigma y by 2 the whole square plus tau square xy, which is equal to, can you tell me, root of root of 80 minus 40 by 2 the whole square plus 60 square. I will write myself tau max, which will be equal to 80 minus 40, which is equal to 63.25 MPa. Now, whether it's max or minimum, you write it as tau max. But we know that since tau max, we have found it from this equation, we should not take the sign of this equation. From this equation, we came to know that, this equation, we came to know that, see here, here it is rotating my sigma t plane in clockwise direction. Hence, my tau will clockwise direction. Opposite phase will be like this, and this arrow will meet like this. This arrow will meet like this, and sigma average we have found. Sigma average is equal to 60 MPa tensile force. We should indicate sigma average 60 MPa, and all the phases is acting 60, 60, 60. Okay, tau max is this expression, sigma x minus sigma y by 2 tau square plus tau square xy, or sigma x minus sigma half into sigma x minus sigma y the whole square plus 4 tau square xy. So what we got is, I cannot say tau max from this expression. What I have to do, I have to find the direction from this expression. If it is rotating in this positive, then it will rotate my S1 phase in counterclockwise direction, or else it will rotate in clockwise direction, it is negative. Have you understood that? You can compare, if this is your local answer, JBK, the problem number 3.9, I think. 3. Yes, problem number 3.9. You can check yourself. If you stress transformation, what you have written in sketch, for example, in this case, there are two options. Follow this convention only. Theta p1, either you can rotate theta p2 and you can write it, okay, 90 degree apart. I will follow this method. He has indicated theta sigma 1 123 MPa. He has indicated that theta 1 is equal to 35. You should not do like that. Either he has not indicated precisely which plane is P1, which plane is P2. You have to follow this method. Theta P1, plane P1 is at an angle 35.7 degree, and plane 2 is at an angle of 3.2. He has indicated theta 1 and theta 1 only. I don't understand this convention. And these are the two planes. Minus 3.2 and sigma 1 at an angle 35.78, and sigma theta p2 are at an angle of 125.78. Okay, we have indicated sigma 1 and sigma 2 on plane p1 and p2, and then we should go for s1 and s2 planes. This is theta s1 and s2. We have found theta s1 and s2. Theta s1 is equal to minus 9.218. Since theta p1 is positive, I should subtract 45 degree from that. I have told you the convention, and then we got minus 9.218. I will rotate minus 9.218 degree in clockwise direction. Since the negative sign, my theta clockwise is negative, so I rotated my x-axis through minus 9.218 degree in the clockwise direction, and obviously 90 degrees. There is a difference, 80% of some angle between TS1 and S2 plane. Okay. And then for indicating the tau value, tau is of magnitude, here you should indicate 63.25 MPa, 63.25 MPa, sigma average 60 MPa, 63.25 MPa. That will come to know the direction by checking the sigma t. If sigma t is negative, it will rotate in clockwise. Sigma t is positive, it will rotate S1 phase in counterclockwise direction. That's all about this problem. Maybe they will ask for 10 marks. This is one problem. If I solve, in case sigma x minus sigma is negative, okay, then theta p indicates the plane p2. That's all. Only two types of problem. There's nothing else. Okay. If you know this, we will do theoretically. We will do using Morse code. There is no much complication on this problem. Okay. I'll stop at this point. Shall I stop at this point?
Yes, sir.
Okay.
Yes, sir.
Thank you.